I'm here with Dave Bodkin, who is the lead systems engineer here at Orbital ATK. Dave, how you doing?
Very well, thanks, Franklin.
So Dave, tell us about the prototypes that you're working with here at Orbital ATK.
So we have 3 prototypes that we're working with. 2 are in the tool family, and the other one is kind of separate to that. The 2 tools are an e-beam welding tool, and so the prototype is going to show that we can grasp onto a truss and perform a welding operation, a tool path. The second tool is a universal grabber tool, and so this tool will be used for placing our solar arrays and also deploying the solar arrays, pulling them out. And then the last one is a quick disconnect, and so this is a mechanical and electrical connection to pass power and data from the solar array to the truss.
Okay, so it sounds like it's like a big erector set that's going to be put together in space.
You can look at that. So what we're trying to show is that we have a toolbox of capabilities, and so we're trying to demonstrate that.
Now tell me, why would you move around solar arrays around on a structure in space?
So there's a lot of times where either a solar panel might have failed or something like that we might need to account for discarding the solar array or moving it to a different location. So we want to show that we can, first of all, integrate it, connect it to the truss in the solar array, but also after we do that, disengage it from the quick disconnect and move it to another location.
Talk to me about using the E-beam to sever, because I think about welding, but I assume it's like using the heat to separate it just like you're using to join it?
Yeah, and so what you'll see is, so we're using electron beam technology, and this prototype that we're working on will actually grapple onto the truss that we're constructing at the joint and create a tool path. And so when we demonstrate this, it will be able to both join and sever. And to create the weld, we'll essentially melt the 2 metals together. When we sever it, we'll up the power some, and we'll be able to cut the metal between the 2.
Why would we want to take structures apart and put them together in space? What's the need?
So as we get into larger and larger space structures, you're seeing the need to actually construct these in space, because we no longer have a launch vehicle that can take these up in one launch or so.
Now, the prototypes that you have here, they didn't take months and years to develop. You actually put these together in the course of like several weeks. Tell us about that.
Right, yeah, so we've taken full advantage of the rapid prototyping. Traditional method for manufacturing things would, you have a design, you release drawings for it, you have to get them checked, you have to go out for quotes, and then finally the parts start to show up. And all that takes about 9 months or so. Our team here has been great. They've been able to assemble these prototypes within a short span of only a few weeks. And so we can go from a concept to actually a full working prototype in just a matter of days.
So after the 3D printing of the prototypes, what will you need to do with those prototypes to get to the ground tests?
We are currently using plastic additive manufacturing. That proves our proof of concept for these various prototypes. Now, as we mature those and go into the ground demonstration phase and actually the testing, we need those to be more robust. And so we will be swapping out the material. Instead of using plastic, we'll be using metal, and we're using additive manufacturing, but using metal as the primary material. So what we see with the rapid prototypes is that we can develop a more robust design in a shorter time span to get us to the ground demonstration. And ultimately what that means for NASA is that we can shorten the time span to get to a flight demonstration as well.